presented a number of motions, pops at the limb, flickering at the active region, and indeed, the sun is waking up. It began as the northern filament had its southern reach puffed towards the equator and continued with the eruptions around the limb and a rise in the X-ray flux. The flares are split between the departing and incoming group on the south. The incoming one has been producing CMEs every few hours as it turns into face Earth. But let's go back and watch 3 days on Soho. We'll first see that far side blast we've previously reported. It was wide and pretty solid density, would have produced a geomagnetic storm if it hit Earth, but that may be about it. Technological impact may have been virtually nothing. But that's not what we can say for the eruption that occurred yesterday. That appears to be just shy of kill-shot level CME production. We can't see the flare class because it was on the far side, but that is major, heavy density. Electrical issues, possibly up to major grid level, may have been expected if that ultra-dense corrugation was aimed at Earth. Lucky us. Let's head out to space next, where not stars, not galaxies, but galaxy clusters collide. The wavelength views offered by Chandra really help visualize just how unfit human eyes are to view the heavens in their true form. Optical to red radio to blue X-ray and a composite. Their model actually works fairly well to produce the sight we see in space, and plasma cosmology folks at this channel will be happy to know it's mostly an interaction of their plasma halos in the X-ray realm. Radio still dominated by the jet features, as expected. A quick nod up next to the scalability from space weather forcing by the interplanetary magnetic field to the galactic current sheet solar forcing. Field-aligned currents heavily dependent on the By component, the magnetic angle of the solar wind, which changes as Earth swims through the current sheet of solar wind plasma. And of course, we have to use our imagination when we scale that up to the sun and the galaxy. Last but not least, let's run this down yet again. We have seen the Earth's rotation glitches going bananas. We've been covering the glitch that has set a new forecasted fastest day of the year, but it keeps getting pushed back and to a faster speed than before. Yet again, we are 1 day later and now over 3 milliseconds fast forecasted for that day. Folks, yes, the day is never exactly 24 hours, and yes, it goes up and down, and that's expected. But 2020, we broke the record for fastest rotation day ever recorded 28 times. 28 times in 1 year, and we're obviously going much faster again this year. No, folks, you won't be feeling milliseconds of rotation change, but the mantle will, the asthenosphere will, and the low-velocity zone locking the crust on top of it will. Faster spin means more energy in from Earth's weakening magnetic field. 2020 was the fastest year ever, and this year